Hi, my name is Nathaniel, and here's my presentation for my research project. My research project is about scientists spotting giant planet which orbits a dead star's corpse. This article can potentially change the way we think of not only dying stars, but also the planets that surround a dying or dead star. This article is from Scientific American. The author of this article is Mike Wall. The now white dwarf planet known as WD 1856 was at one point a huge star. It's part of a 3-star system, 80 light years away from here. The star then ran out of hydrogen fuel, as all stars will at some point do. It eventually became a white dwarf. During this process of becoming a white dwarf, it destroys the surrounding planets and stars. What was mind-boggling to scientists was the fact that a Jupiter-sized planet survived this and is now orbiting the white dwarf as its star. Is what scientists thought about the destruction of dying stars not as true as they imagined? The typical white dwarf formation destroys everything surrounding it. So why is this planet any different? Why am I interested? I care because, coincidentally, this relates to our current chapter, which explores interstellar space, which is basically meaning that it's the space in between stars and the process of stars' death and its birth. I am also interested in this article because it has the power to reshape certain ideas that astronomers have set in place, which could lead to many other discoveries. Who knows what one simple observation could do? Possibly the findings of habitable planets, other life forms on Earth, or even just new information on stars, planets, and other celestial bodies. This discovery especially attracted the attention of TESS, or the Transitioning Exoplanet Survey Satellite. The team normally deals with planets, so an article about a white dwarf may seem irrelevant. TESS specifically tries to find alien worlds by taking note of their brightness dips. The members of TESS who further explored this planet and this star behavior were Vanderberg and his colleagues. Another team that further explored information for this article is the director of Cornell's Carl Sagan Institute. WD 1856 is also 7 times bigger than the white dwarf that it is orbiting. This planet makes a complete rotation every 34 hours. However, this article is more about a planet that has been orbiting a white dwarf after its death. Many speculate the planet was far out of reach by the time white dwarf had its very explosive death. However, many scientists speculate that the planet couldn't have been that far since it is now in its orbit soon after its death. Even if it was, though, anything that gets too close to a white dwarf, even after its formation is complete, is usually torn apart by the star's gravity. Another interesting speculation is that if the gas giant that is the planet WD 1856 can survive a star's death, what if Earth can survive the sun's death? Especially since Earth has a rocky terrain and therefore is more likely to survive. Many scientists suggest that the planets that are similar to WD 1856, in other words, planets that are able to survive the massive destruction that can come from a star's death, may be habitable. In the right conditions, those worlds can maintain excellent conditions that could greatly surpass Earth's, not only in its resources but also its lifespan. Even though we have billions of years to explore, why not start now? In the end, this article presents many possibilities for what astronomers continue to theorize about planets, stars, and other objects. It is an estimated 5 billion years until our sun destroys Mercury, Venus, and possibly Earth. Could planets that can survive the sheer power and destruction of a dying star be the answer? What is the name of the planet that this article was based on? What is one aspect of this article that may change the way scientists think about astronomy? Was the star a white dwarf, a brown dwarf, or a red dwarf? Thank you.